In this video, I'm going to show you how to calculate the standard deviation of some data that you collected in lab. So let's say that you did a synthesis of aspirin lab where you synthesized aspirin and you determined your percent yield. So you have a bunch of different groups reporting their percent yield, and we're going to determine if the percent yield that you got falls in line with the rest of the class's data. And the way we're going to determine that is if it is within 2 standard deviations of the mean, then your data will be good. So let's look at some data that was collected by the class. Group number 1 got a 58.5% yield. And group number 2 got a 52.0% yield. Group 3 got a 55.2% yield, and group 4 got a 56.3% yield. So the first thing we have to do is calculate the mean. All right, so to determine the mean, that's just an average. So that's pretty easy. We will first add up all the percent yields. Okay, and that should give us about 222, and then we have to divide that by how many groups we had, right? So 222 divided by 4. This is going to give us 55.5% for the average. All right. Then for step 2, we have to determine the deviations from the mean. What that means is you have to take your data point, your percent yield in this case, and figure out how far it is from the average. And we're going to do that for each of these groups. So we're going to take the absolute value and find out how far away each group's percent yield is from this average of 55.5. That is a deviation from the mean. So I'm taking the absolute value here. I don't care if it's positive or negative. I just want the difference from every group's data from the mean. All right, so this one here will end up being 3.0. That's how far away their group's percent yield is from the average number. Then I'll do that for group number 2. Again, I'm finding what's called deviations from the mean. So how far does each group's data point differ from the average? This one is negative 3.5, but remember I'm taking the absolute value, so I just care that it's 3.5. The next one is the absolute value of 55.2 minus 55.5. And that is 0.3, and I am taking 56.3 minus 55.5 for the last one, and we get 0.8. So these are all of our, these numbers right here are all of our deviations from the mean. Now what we're going to do with those is step number 3, we're going to plug into the formula for the standard deviation. So let me show you that. Okay, so the standard deviation formula is equal to the square root of all of these deviations from the mean squared and added together. So I'm taking this first deviation, I squared it, I'm adding it to the second deviation from the mean, squared. I'm going to add that to the third deviation from the mean, squared. And then I'm going to add that to the last one. So I'm squaring all the deviations from the mean and adding them. And I'm going to divide that by the number of trials minus 1. So that's your formula for the standard deviation. You always get the mean first, then you take all the data points and get the deviation from the mean. Then you take the sum of the squares of the deviation from the mean and take the square root of that divided by the number of trials minus 1. Okay? So what I got here on the denominator, that is the number of trials in this. So we had 4 groups, so we have 4 trials, and then we do minus 1 at the bottom. So let's see what all this adds up to. Looks like we have the square root of about 11.6 divided by 3. I think this should be about 21.98 actually, divided by 3. And then we take the square root of that, and we should end up with about 2.7. Alright, so our standard deviation is about 2.7, and if you remember what we're getting the deviation of here, this was an aspirant synthesis lab, so all of our data points up here were percent yields in this particular experiment. So this standard deviation over here, this is going to be a percent. So what do we do with this? We can report our final answer from this lab as the best number to represent what we think we should get from this lab is the mean, the average of all the groups, which was 55.5%, plus or minus your standard deviation, which was 2.7%. So plus or minus 2.7%. Okay, this is what our final answer is. So is your data good? Here's basically how you determine if your data is good or not. Good data falls within 2 standard deviations of the mean. Okay, so since our deviation was 2.7%, 2.7 times 2 is going to give us 5.4%. So when you look at the average of 55.5, you have a range. If you are 5.4% below it, okay, that would mean good data at a minimum has to be 55.5 minus 5.4. The lowest range we should see that's acceptable data is 50.1% yield. Okay, you could also go 5.4% above the average, which would be about 60.9%. So this range just gives us kind of our low to high range. As long as your data falls in this range right here, 50.1% yield to 60.9% yield, that is good data, right? Because it's within 2 standard deviations of the mean. So we could look at and ask ourselves, was the, if maybe you were group number 2. Let's go back and look at group number 2's data. Group number 2 had a 52% yield. So how do they determine if their data is good? Well, did it fall in this range within 2 standard deviations above or below the mean? And yes, it did. Their data was 52%, and that's right in this range right here. So their data is good. And essentially, those 3 steps there, getting the mean or the average, getting the deviations from the mean, and then plugging into the standard deviation formula, which is the square root of the sums of the squares of the deviations of the mean divided by the number of trials minus 1. That will get you the standard deviation.